Hello everyone, welcome to the lecture. My name is Devananda Rao, the Department of CSC, MLR Institute of Technology, Hyderabad. Today's topic is source language issues. As execution proceeds, the same name in the source text can denote different data objects in the target machine. That means a variable declared inside a function might have a different scope from one declared outside the function. For example, there is a function void my function A is a variable declared as integer with assignment 5. If you print this A, will get 5. Suppose in a main program when you call my function, here A is declared in the function with value 5 and the scope of this variable is different from the variable declared in main function. Here 5 is assigned, here 10 is assigned. When you call the function my function, the control goes to my function, there I will print the value of 5, value of A as 5. In main function, we will declare a variable A and assign 10, we can print the value of A as 10. Here same name in the source text can denote different data objects in the target machine. That means a variable declared inside a function might have a different scope from declared outside the function. Each execution of a procedure is referred to as an activation of the procedure. If the procedure is recursive, several of its activations may be alive at the same time. When you call a procedure, an activation record is created. So, the procedure is active. If the procedure is recursive, several of its activations may be alive at the same time. So, you can understand this with the example. Factorial of n, if n equal to 0, return 1, else return n into factorial of n minus 1. Then result is factorial of 5, n value is 5, print result. This is the Python program. Here the function name is factorial. If you call factorial with the value 5, an activation is created, activation record, the function factorial is active for factorial 5. So, as 5 is not equal to 0, as 5 is not equal to 0, else part will be executed. Else part, that is n into factorial n minus 1, that is n into factorial n minus 1. Now, factorial 4 is called under factorial 5. Inside the factorial 5, factorial 4 is called. Now, 4 is as 4 is not equal to 0, else part will be executed. In else part, return n into factorial n minus 1, that is 4 into factorial 3. Now, factorial 3 is active inside the factorial 4. So, this will continue until when we reach factorial 0. Factorial 0 returns 1. So, that for the same recursive procedure, several of its activations may be alive at the same time. Source language issues. Procedures. A procedure definition is a declaration that associates an identifier with a statement. Here, identifier is a name of the procedure, statement is the body of the procedure. Identifier is the procedure name and statement is the procedure body. Every procedure having a name, procedure or function name, that name is called identifier. We can call the function with the function name, procedure with the procedure name, that is called identifier. and the body of the procedure is called statement. When a procedure name appears within an executable statement, we say that the procedure is called at that point. The basic idea is that a procedure call executes the procedure body. In this example of quicksort, here this is not complete quicksort program, it is a snippet of the quicksort program. Main program having two functions, read array and quicksort, along with some declaration integer n. Read array and quicksort are the two functions. First, in the during execution, read array function will be called, so that control will go to read array function. Here the execution will be stopped and control goes to read array function. The definition of the read array function, there the read array will be executed for reading the array of elements. After that, control come back and execute quicksort with elements 1, n. Then when you execute quicksort, before calling the quicksort, read array is ended. Then control goes to definition of the quicksort with the formal parameters n and m and n are the formal parameters. In this quicksort having functions, partition function to partition the elements, so that after partitioning elements, once again the quicksort is the recursive function. The quicksort is a recursive function, that is a procedure can call itself. That means quicksort m I minus 1 and quicksort I plus 1 n. So that several activations of the quicksort may be alive at the same time. So when you call partition inside the quicksort, the control goes to definition of the partition. There the statements will be executed. After completion of the partition, come back to quicksort, there continuation of the execution. Activation trees. If A and B are the procedure activations, then their lifetimes are either non-overlapping or nested. That is, if B is entered before A is left, then control must leave B before it leaves A. In the previous example, read array is a function. For read array function, there is a node in the activation tree, and quicksort is a function, there is a node in the quicksort. So that before quicksort, read array is called, so that read array function will be executed. After that, quicksort will be executed. Coming to this, if B is entered before A is left, then control must leave B before it leaves A. That means quicksort is a recursive. Before completion of quicksort for m, n, here quicksort m, I minus 1 will be entered. So before ending quicksort of m, n, quicksort of m, I minus 1 will be ended. Then activation tree, the way control enters and leaves the activations. Activation tree shows the way control enters and leaves the activations. Each node represents an activation of a procedure. There is a tree having root node, having internal nodes and leaf nodes. Each node represents an activation of the procedure. The root node represents the activation of the main program. In the previous quicksort program, main program is the root node of the tree, and read array and quicksort 1, n are the children. The node for A is the parent node for B if and only if the control flows from activation A to activation B. See, main is the parent, read array is the children. So flow going from main to read array, so that main is the parent. The node for A is the left of the node for B if and only if the lifetime of A occurs before lifetime of B. In this example, read array occurs, lifetime of read array function will occurs before lifetime of quicksort 1, n. So that the node for read array will occurs left side to the node for quicksort in the activation tree. So this is the activation tree representing calls during the execution of the quicksort. M representing the main program, so that main program is the root node of the activation tree. R is the read array, R representing node representing that read array. That means this read array function after the quicksort, so that lifetime of read array will occurs before lifetime of quicksort, so that read array node appears left side to quicksort 1, n. Read array node is left side to quicksort 1, n. Here n is 9. Then when you call quicksort 1, 9, that is 1, n, first it will call partition 1, 9. After partitioning, control goes to q 1, 3. Then after completion of this q 1, 3 only, q 5, 9 will be executed. Like that, it will control flows from top to bottom. First activation of main will be entered, then enter read array, then leave read array. This will be completed. After that, enter quicksort, enter partition, leave partition. After partitioning only, we will go to Q13. Then enter quicksort 13, then leave, and this will continue until after this. For example, Q5, 9 will leave after leaving all these nodes. Finally, quicksort 1, 9 will leave. Finally, main activation will be ended. This diagram representing possible activations for the program of quicksort. Control stack keeps track of live procedure activations. Push the node for activation onto the control stack as the activation begins. Pop the node when the activation ends. So, M representing main program, R representing read array, Q representing quicksort with the parameters 1, 9 like that. So, frame for main, it is a control stack. This is the downward growing control stack. Downward growing control stack. That means in main program we have variable A, array A of type integer with 11 elements, so that for that array a memory is reserved in the stack. In main program we have variable array variable A with 11 elements, memory is stored. Next, B diagram. After main, we will call read array function. For read array, activation record will be pushed onto the stack. Activation record will contain parameters and return address and other information of the function. So, each function having activation record. Whenever a procedure is executed, activation record of that procedure will be created and pushed onto the stack. So, after main, read array will be executed. Activation record of R will be pushed onto the stack along with some information. Now, in this diagram, R is activated. After that, after read array function is completed, control goes to quicksort. In this diagram, dash line representing ended of the procedure. Here, dash line representing read array function is ended. So that we can pop that read array activation record from the stack and push quicksort activation record for quicksort 1, 9 along with the formal parameters m, n. After that, still quicksort 1, 9 is alive, we will control goes to partition. That is, for partition function is whenever partition function is active, the activation record will be created. That activation record will be pushed onto the stack. See this. Still quicksort 1, 9 is active, then we will push this diagram main function, this dashed line representing read array function is completed. After that, quicksort 1, 9 still active, and after that partition is alive, and after that we will pop the partition from the quicksort. Then after that we will call quicksort 1, 3. These two are alive. Quicksort 1, 9 and quicksort 1, 3 both functions are active, so that both activation records are pushed onto the stack. So that for the recursive procedure, several activation records may be alive at the same time. This diagram showing downward growing of stack of activation records. Then the scope of a declaration. A declaration in a language is a syntactic construct that associates information with a name. Here name is a variable name. This is the Pascal declaration, Pascal language declaration. Pascal language declaration. I is the variable var where I colon integer. I is a variable name of type integer. Like that we can declare. A declaration is a language construct, language syntactic construct that associates information with a name. Next, binding of names. The term environment refers to a function that maps name to a storage location. Name is a variable name, storage location. For every variable name, a location is mapped. For a location is mapped. A location is mapped. And the term state refers to a function that maps storage location to a value held in the a variable a. For example, a is 10. So then 10 is assigned to a storage location. When an environment associates a storage location S with a name X, we say that X is bound to S. Mapping names to variables. So environment maps name to storage location, state map storage location to value. So that mapping name to storage done at compile time, then mapping storage to value done at runtime. Here I is a variable, I is assigned to 0, I is incremented by 1. That means environment and states are different things, different functions. That means an assignment changes the state but not the environment. That means the assignment, for example, I is equals to 0. This is assignment. Changes the statement. The value in the storage will be changed, but environment will not be changed. The location will not be changed. Thank you.